Hello everyone, let's start. I told you in the earlier classes also that if you are having question of sequence, series or trigonometry, so you can take the help of the example also. See, ABC are in GP. So the simple numbers which are in GP is 1 to 4. So just check which option satisfy this. Option A, 1 square, 2 square, 4 square. So 1, 4, 16. They are in GP. So option A is correct. Now check option B. So A square, B plus C is 2 plus 4, C square is 16, then A plus B is 3, B square is 4, A plus C is 5. So they will form 6, 48 and 20. So they are not in GP. In the same way, when you check option C, it will also not form a GP. Yes, any doubt here in this? So here also you have options to take. ABC are in AP. So ABC you can assume 1, 2, 3. XYZ are in GP. So XYZ you can assume 1 to 4. And there is no restriction that A cannot be equals to X. Okay. So just substitute the values. So X to the power X is 1. B minus C. Common difference is 1. Y is 2. Common difference is 1. And Z is 4. Okay, now here C minus A is there. So 3 minus 1, 2 is there. So here, okay. And here A minus B. So minus 1. So that becomes, so we can directly find the value. See, this is formula based. If you don't remember the formula, then we cannot do this. Okay, so formula is coefficient of variation is standard deviation by mean into 100. Basically, it is the percentage thing. Okay, so for the first, we have coefficient of variation as a 50 and the arithmetic mean is 30. So 50 equals to first standard deviation by 30 into 100. So first standard deviation is 15. In the same way, 60 equals to second standard deviation upon its respective mean. So this also comes out to be 15. So the difference comes out to be 0. Okay, so just remember this formula. They ask sometimes this on directly on this. See, this is a verbal question. Just by looking at the SN of an AP, you can directly tell its common difference as well as its first term. So, what is the concept basically? If suppose you have a general term Tn, which is in the form of An plus B, general term of the arithmetic progression will be of this form. So, first term is T1. Just substitute n equals to 1. You will get the first term, and common difference will be coefficient of n. Whoever is the coefficient of n will represent the common difference of the AP. In the same way, if Sn is there, so let's say Cn square plus Dn. So first term is when you substitute s equal to 1, n equal to 1, so it becomes C plus D. Common difference here is 2 times of coefficient of n square. Okay, so who is coefficient of n square? 1. So 2 times of 1 is common difference. So this will save your time. Okay, just remember this. And this can come from the generalization basically. Okay, it's not like there is a short trick basically. Okay, yes, any doubt here in this? Okay, this also we can solve it verbally. Okay, if we just apply the property of AP. See, there are general approach also that if there are 51 terms, 26 term will be the middle term. You will find T26 equal to 300, find some relation between A and D, and then put in the S51 and simplify it. One way. Okay. Second way, the property of AP. Now, suppose see, there are odd number of terms. Okay. If I take a very simple example of AP 1, 2, 3, 4, and 5, there are 5 terms in the AP. Okay. If you know the middle term, right? And someone says find the sum of all the terms. So see, what is the sum of the first and the last term? 6, 6. And this middle term, you come from this side and you come from this side, so you will get the 2 times of the middle term. But in actual sum, you will get the middle term only once. Okay. So what we just do is 300 is the middle term. So 2 times of middle term is 600. So basically this 600 represents the sum of the first and the last term of an AP. So how many pairs will be there if you, in 51 terms, how many pairs will be there for first and last term, second and second last term? 25 pairs. So 25 into 600. But the middle term will be left out. So middle term is 300. So that will give you the sum of the Yes. Any doubt in this property? So this is the series expansion of e to the power x. E to the power x is 1 plus x upon 1 factorial x square upon 2 factorial like this. So in place of x, what we have is log x base e square. So this becomes e to the power log x base e square. So in order to simplify, we want this base and this base to be same. So let's transfer this 2. So this 2 will become 1 upon 2 when it comes in front of the log. Now we can write like this. So this becomes root x. Yes, any doubt here in this? See, if it is not clear, it is written as a to the power log 7 base 3 equals to 27. This is b to the power log 7 base equal 11 equals to 49, and c log 25. Okay, and here same thing is written a to the power log 7 base 3, but log 7 base 3 has power 2 now. Okay, same here. See, very basic power manipulation is there. Here you have given a to the power log 7 base 3 equal to 27, but they have asked here the power square. Now suppose if you have given, let's say, a cube equal to 5, and they have asked you a9. What is a9? What you will do? Anyone? What we will do to get a to the power 9? In the first one, we do power 3 on both the sides. So it becomes the square of the power. So similarly here, if this is given, and if I want the square of the power, so what we can do? Take both the sides, power log 7 base 3. So this becomes power square, and here it simplifies to 27 is 3 cube, so 3 to the power 3. So this can be written as 3 log 7 base 3, which becomes 3 to the power 3, sorry, 7 to the power 3. Okay. In the same way, when you take both the sides, the power, log 11 base 7. So this is 7 square, which can be written like this. So it becomes 11 square. And the last one, c to the power, when you simplify again the same thing, we will get 5. So total will be, which comes out to be option B. Yes, any doubt here in this, anyone? So our mean is variable into its frequency until n into ncn p to the power n divided by sum of all the frequencies So in the denominator, we can clearly see it is the binomial expansion of p plus q. Okay. And in the numerator, it is 1 into nc1 qn minus 1 pn, 2 into nc2 qn minus 2 p2 until n into ncn p to the power n. Okay. Now p plus q, they have already given us 1, right? Now, this thing we have to evaluate, right? So what we can do here is, here we have 1. If I take the sum as s, right, and taking from 0, 0 into nc0 q to the power n, 1 into nc1 q to the power n minus 1 p to the power 1, 2 into nc2 q to the power. Let's only write the last one, n into ncn p to the power n. If I write the series in the reverse way, right? So n into ncn p to the power n. Okay. But if we do like this, okay, so there will be Pn and Qn which will not be common, so we cannot add them directly. Okay, so what we can do next is, let's generalize this thing. So we can write like this, summation r equals to 1 to n, r into ncr q to the power n minus r p to the power r is 1, if r is 2, like this. Now, the main thing which is creating the problem is this r. So we have the property of NCR, that NCR can be written as n upon r, n minus 1 CR minus 1. You can take out this n and r out of NCR and subtract 1 1. So we can write like this, n upon r, n minus 1 CR minus 1 q to the power n minus r p to the power r. So this r got removed, n is a constant for this summation. So you can take out this n out of this. Now, this becomes binomial expansion if it matches with the general term. So what does general term says? Whatever is written here, same power should be present in either one of the two terms. So here in P, only R is present, not R minus 1. But in Q, the difference of the power is present. So this Q is perfect at its position in terms of general term. But here the P power should be R minus 1. So what we are doing is, we can take out one P out of this. So it becomes, and now this again becomes the summation of P plus Q. to the power n minus 1. Yes. Any doubt here in this? Okay. See, if you try to find the value of the alpha and beta, that comes out to be in the complicated form. Then you put this, simplify it. So that's not worth the time, basically. Okay. So, see, if we have a very good fundamental understanding of the quadratic, then this question is solved within 1 minute. So, how we can solve it? Now, see, if you have a quadratic like this, ax square plus bx plus c equal to 0, which has roots alpha and beta. So, you will write sum of the roots as minus b upon a, product of the roots as c upon a, right? Now, here in this situation, we have a quadratic in log, which has roots alpha and beta. So now here you cannot write sum of the root is 4. This is incorrect. Okay, this is not correct. Because see, when you are putting the alpha, so this thing becomes log alpha base 2. Okay, so log alpha base 2 is satisfying this equation. Okay, here what happens is directly x is satisfying the equation. That's why we write the sum of the roots and product of the root, because it is a quadratic in x. Now it is a quadratic in log x. So what you have to write is log alpha base 2 log beta base 2, that is sum of the roots. In the same way, log alpha base 2 log beta base 2 is the product of the roots. So now when you have to find log alpha base beta plus log beta base alpha, we can break this into the base 2 form. So when you now take the LCM, it becomes log alpha whole square, log beta base 2 whole square by log alpha log beta base 2. So this becomes a square plus b square. So we can write this thing as a plus b whole square minus 2ab divided by, now you know every value, product, sum, so just substitute it. So when you substitute, you will get option D as the answer. Similarly, if the quadratic equation is in the form of e to the power x, e to the power, let's say 2x plus 3 times of e to the power x minus 5 equal to 0, and its roots are alpha and beta. So the sum of the roots will be e to the power alpha, e to the power beta, that is minus 3, and product of the roots is e to the power alpha, e to the power beta equals to minus 5. Now see, they are asking product of roots. So alpha and beta is basically a product of roots, right? So you have to find alpha and beta. So here product of roots, this is not the product of roots. This is the comparison, that how you write it. Okay. Yes. Any doubts here in this? So now here, when we open the terms, okay. So after taking the LCM and everything, first term will be PR plus PQ upon QR. Second term will be QR plus QP upon RP. And this is RQ plus RP upon PQ, right? So in numerator, you can see the missing term is QR. Here the missing term is RP and PQ. So if these are in AP, and if I increase every term by 1, because we want to create the same numerator in every term. So we can eliminate the numerator. Okay. So these terms are still in AP. So the numerator will become PQ plus QR plus RP. Here also the numerator will become PQ plus divide numerator with, sorry, divide every term with the same numerator. So the terms become 1 upon QR, 1 upon RP, 1 upon PQ. Multiply every term with PQR. So this will become PQR. So they are in AP. Yes, any doubt in this, anyone? So sum of n terms of the GP is A, r to the power n minus 1 upon r minus 1. Sum of two n terms will be A, r to the power 2n minus 1 upon r minus 1. So they are asking the ratio of these two. A got cancelled out. We are left with this thing. The numerator we cannot factorize, but denominator, it is a square minus b square. So you can write like this. This got cancelled out. So 1 upon 1 plus r to the power n. Yes, any doubt in this manipulation? Almost everyone answered it. This is a verbal question. See, every term is at the same distance, 6 units. So y will be basically the geometric mean of x and z. So y will be root xz. So S1 is basically the T1, 4 minus 3 upon 3, 1 upon 3. S2 is basically the sum of the first two terms. So 4 square minus 3 square upon 3 square. So T2 will be 7 upon 9 minus 1 upon 3. I guess everyone solved it so fast, so I assume everyone has taken the example. Let's say m is 2, n is 1. Okay, so this becomes the third term of the GP, which is P. This becomes the first term of the GP, that is Q, and you have taken m as a 2. So we are asking to find T2. So if we know first and third term, T2 will be the geometric mean of this. So root PQ. Yes, any doubt in this assumption? Everyone got it correct. Sum of an infinite GP means a upon 1 minus r, that is 9. So let's find a in terms of r because we have to find r in the end. Sum of the first two terms a plus ar is 5. Taking a common, substitute the value of a. So 1 minus r square 5 by 9. So r comes out to be plus minus 2 by 3. They have given only plus value, so Now see, we know the formula for sum of first and odd natural numbers, right? This is the formula is n square. If you open this thing, so it starts with 3, 5, 7, and it will go towards 2n plus 1. Okay. Now, as per this formula, our sequence should start with 1. So, what we can do is, I'm shifting that 1 here. So, 1 plus 3 plus 5. And before 2n plus 1, there will be 2n minus 1. And since you have shifted that 1 here, it remains 2n. Now, this formula is n square plus n. They have given this thing as. So, n into n plus 2 is 440. So, just we have to break 440 into two numbers which differ by 2. So, if n is 20, n plus 2 is 22. So, we'll got answer. Okay, so one way is you can open this thing. You can apply the sum of first and natural number in this. This becomes total n, then you can simplify. But if you go like this, you will save some time. And this thing, everything you can do in your mind also. Okay, it's not like you have to write it down every point. Rayesh and Anuj, you are saying option 3 and 2 or the solutions basically. Okay, there is no option for exactly 3 solution. Okay, so option 3 is correct. Okay, so you can see the input or the domain of the log is positive. It means that value of x must be negative, then only this value will become positive. So first we got the domain that x is negative. So here it becomes log of minus x root equals to log of, now see, if x is negative, then this will come out as a mod x, and mod x will open with minus x. Clear? Now, one thing is that you can shift this LHS on to the RHS. Take out root log of minus x base 10 as a common. So this will become, so if this is 0, so this will become 0 when x will become minus 1. So one solution. When this is 0, it means this thing is becoming 1. So x will be minus 10, then only 10 and 10 will become 1. So there will be exactly two solutions. Yes, anyone have doubt in this? Here also we can verify using the options. If I put n equals to 1, S1 will represent the T1, that is 5. In which of the options you are getting 5 when you put n equal to 1? Option C. So this is based on the property of variance, that suppose if you have observations x1, x2 till xn, whose variance is this. If I increase each observation with some constant, so this will be the new set of observation, but the variance remains same. Okay. But if we multiply each observation with say constant, some constant, the variance will become lambda square times of the previous variance. So here which operation is happening? You are increasing each observation by 50. The variance will remain same. Okay. So this property everyone should remember. If x, y, z are in AP, then 2y equals to x plus z. Similarly, 2 times of tan inverse y equals to tan inverse x plus tan inverse z. How we simplify? Take tan on both the sides. So this becomes tan 2 theta formula. So 2 tan theta. So tan of tan inverse y will become y minus 1 minus this. Similarly, here it becomes tan a plus b formula. So a plus b upon 1 minus ab. So 2y and xz is equal. So they get cancelled out. So 1 minus y square is xz. So y square comes out to be xz. Now if the three numbers are in AP and the three numbers are in GP, then this is only possible when the numbers are equal. Okay. Any doubt in this, anyone? This is S1 into 1 plus S3 by 4 upon S2's whole square. So our S1 is sum of first 10 natural numbers. Our S2 is sum of squares of first 10 natural numbers, right? And then our S3 is cube of sum of cubes of first 10 natural numbers, right? Now let's put this into this. So limit this whole square. So n into n plus 1. Okay, now see, this n is already outside. So whenever n is tending to infinity, we basically wants to cut out the highest power of n in the numerator and denominator. So now see, from here I will take n common. Okay, from here, what is the highest power of n? N to the power 4. So we will take out n to the power 4 common out of this. Okay, so you can see n to the power 4 and n to the power 2. Total power comes out to be n to the power 6. Here n square, this n will comes out as a n square. This way n will also comes out as a n square. So see how it becomes n. Now I take n common out of this, so it becomes 1 plus 1 upon n by 2. Here 1 plus, first take n common out of this, so this becomes n square 1 plus 1 upon n by 2 square 4, 4, 4, 16, and this is still in the square. And from denominator, taking n common from every bracket, this is 36 and this is perfect square. Okay. So now when I take n square common out of this, so it comes out to be n to the power basically 4 I am taking common. So this thing becomes n square n to the power 4, 1 plus 1 upon n, and here it becomes 1 upon n to the power 4 plus 1 plus 1 upon n, and in the denominator n to the power 6. This part completely got cancelled out. Now when you substitute n equal to infinity, these terms will become 0. So we are left with 1 upon 2, then 1 upon 16. In the denominator it is 1 square is 1, then 2 square upon 36. So it becomes 36 upon 2 into 4 into 16, cancelling out with 4. So 9 and 4. So this becomes 9 by 32. Yes, any doubt here in this? Here you need to have some patience. This will take time. So if they give you this kind of question in the K-CET or bit set where you have to attempt the questions in 1 to 2 minutes. So if you feel this is going lengthy, you can skip and move on to next question. Okay, if you get time in the end, then you will again try this question. Okay, but don't waste time in such question. It will take you around 2 to 3 questions time. So if the lines are concurrent, then the value of that determinant will be 0, formed by the coefficients of x and y in the constant term. And then 1. Okay. So we cannot take anything common out of this. So let's just open it. So starting with first row, 3bc minus 4bc minus 2a, then c minus b plus a, then 4c minus 3b. Okay. So minus b into c minus 2ac plus 2ab plus 4ac minus 3ab equal to 0. So this becomes minus 2ac will become plus 2ac, 2ab, and this will become minus ab. So 2ac comes out to be bc plus ab, taking b common. So this comes in the HP. Yes, any doubt in this, anyone? So this we have done it in the trigonometry also, but in different format. Here it becomes e to the power log 10. These are in the multiplication. And this we have solved in the trigonometry. This value is 1. So log 1 is 0. So e to the power 0 is. Okay. So this is theoretical question. Domain of logarithmic function is not real. We cannot take negative values. Range of the logarithmic function is not only positive real number, it is negative also. Point 1 comma 0 always lies on the graph. So if whenever we give 1 as a input, we always get 0 as output. So 1 comma 0 always lies on the graph of logarithmic function. The graph of the logarithmic function as we moves from left to right decreases. So it does not decrease. The graph is like this. So it increases when you move from left to right. Just by interchanging the power, it becomes confusing, right? But look at the base.
क्या बात कर रहे थे मैं कॉलेज
Okay. So just convert b in the form of a. So from here, b to the power 5 is 1 upon a to the power 4. So b will be 1 upon a to the power 4 upon 5. So just substitute the value of b here. 1 upon a to the power 4 upon 5 and whole power will be 4. So this becomes a to the power 5 and this becomes a to the power minus 16 by 5. So when you simplify this, it becomes a to the power 9 by 5. Yes, any doubt here in this? Let's make the base 2 in every log. So this will become log x base 2, 1 upon 2 log x base 2, in the same way 1 upon 3 and 1 upon 4. Take log x base 2 common. So 1 by 2. Same is 12. So 12 plus 6 plus 4 plus 3. So that becomes 18. So this is 25 and this cancels out to be 3. Right? So x is 2 to the power 1 by 3. Last minute for this. So one way is to check by putting the options. But if what if they ask you that how many solutions this equation have? So we should know how to solve this thing basically. Okay. So now see who is creating the problem, this free x, right? So there are other logs which has log base 15. So can we write this x like this? So that everything will go in the log base 15 form, and we can write like this. So your LHS will become 15 to the power x into, and this becomes 5 to the power x into. So 5 to the power x will get cancelled out from both the sides because it cannot become 0. So we are left with 3 to the power x. So this is basically a quadratic. So see, when x is 1, then only this quadratic will have root. Or if you want to solve it, let's assume this thing as a t. So the quadratic will be 5t plus t square equals to 24. So when we factorize this, t minus 3, t plus 8, and t is your 3 to the power x. So 3 to the power x will only be equal to 3. Yes, any doubt here in this? When log and normal x are together, you have to somehow manipulate this x into the log form because this log cannot be manipulated further. So when we simplify this 16 will come forward. So this will become 4 log x base 3 and this is in the root. Here it will become 9 log 27. Here the power of base is 3 to the power 3 and this is 3 upon x to the power 1 upon 3, right? So 4 log x base 3, 9. This 3 will come as a 1 upon 3 and this will directly come as a 1 upon 3, right? So this becomes 4 log x base 3 root plus 1 minus log x base 3 equal to 5. So if we assume this thing as a t for a moment, okay, so we have 40 plus 1 minus t square equal to 5. So t square minus 40 plus 4. So this becomes the perfect square of t minus 2. So t is 2 and t is what? Log x base 3 root. Yes, any doubt here in this? This is similar kind of question that a to the power 4, b to the power 5 thing. So convert just everything into the t. So p will be t to the power 7 by 3, q will be t to the power 7 by 4, and s will be t to the power 7 by 2. Just substitute these values so it will comes out in the form of t. Then there is only calculation left, which when you solve, you will get option D as the value. Yes, any doubt here in this part? This is the main thing which we have to think. So the relation between mean, mode, and median is mod equals to 3 median minus 2 mean. And if you face difficulty in remembering this, so you can remember like this: 3 minus 2, 1. Okay. So mod equals to 3 median minus 2 mean. Now they have given that the difference between mean and mod is 63, and we are asking for the difference of mean and median. So we have to remove this mod. So mod is 63 plus mean. So 63 will be equals to 3 times of median minus mean. Yes. Any doubt here in this? Uh, See, whenever you have this probability distribution and you have to find standard deviation, what you have to do is we never directly find the standard deviation, we always find the variance. So formula for the variance is 1 upon n summation of fi into xi whole square minus mean whole square. Okay, this 1 upon n is with only this term. This is the formula. So here xi is this, the data, and in place of fi you have now probability. Okay, and n is what? The summation of the probabilities. So summation of the probabilities, here it is summation of frequency. Now these are the frequencies, so the sum will always be 1. Okay, so that's how you have to apply the variance formula for this table. That's it. This probability is the frequency. That's it. There is nothing new in this. Okay. So that's it for today, everyone. Thank you for joining.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.
Okay.